Hi class, today we're going to learn about the infamous angle side-side situation for triangles. We all know that angle side-side is not a way that we can prove two triangles are congruent, but that was in geometry. In pre-calculus, we're not proving that two triangles are congruent anymore. We're just solving a triangle. We're finding all of its angles and all of its sides. So it's possible that we're given a triangle where we are given a side, and then an angle, and we need to find the rest of the information about that triangle. The problem with side, angle, let's keep it PG and write it this way. The problem with side, angle is that it actually creates two different triangles, or it could possibly create two different triangles. Notice over here, this side length is still 2. Just like the other red triangle in figure 1. And this purple triangle is completely different than figure 1. But that side length is still the same. The side length of 2 is still the same. So let's look at this with a better visual. Okay, this is what could possibly happen when you're given an angle, a side, and another side. There are 3 different scenarios. The first scenario, see here we are given angle A, then we are given side B, and side A. So we're given angle, side. The first scenario is that A is too short to reach the ground, and it cannot create a triangle. So that's our favorite, because when we solve that, we're going to write does not exist. There is no triangle that exists there, and we get to cross off the whole problem and write DNA. No math involved. And you'll see what that looks like later. So, first scenario, that third side is too short and it does not create a triangle at all. Second scenario, in your eyes is the worst, but my eyes is the most awesome, is we could create 2 completely different triangles. So, based on this side A, here A is 6.3, and it creates this giant triangle, or you could swing that side A to the left, and it will create this tiny blue triangle, still with the same exact side length. So given an angle, this angle A is not going to change, because we're given angle, side. So that angle is not going to change. This side is not going to change. That third side is not going to change. That side A is not going to change. But it creates 2 different triangles. So that is case 2. We will create 2 different triangles, and we will have to solve twice. We will have to find all the angles and all the sides of the giant red triangle, and then we will have to find all the angles and all the sides of the blue triangle. Okay, that is case 2. I said there were 3 cases, so what do you think case 3 is? We can have no triangles, we can have 2 triangles. Oh yeah, what if that side length is perfect? What if that side length is perfect? Perfect is clearly hard to come by. What if that side length is perfect? What if A is 4.5 in this case, not always, but what if A is 4.5 and it creates 1 perfect triangle? Okay, so this is why angle, side didn't work in geometry, because there's so many different things that could happen when you're given an angle, a side, and a side. There's 3 things. You can have 2 triangles, 1 triangle, or no triangle. Okay, let's go back to our notes. So, now that we know that there could be 2 triangles, no triangles, or 1 triangle, let's talk about how we're going to solve that. So, as you saw on our visual aid, this side length right here was swinging back and forth, and it created 2 separate triangles. Now, I need to figure out how are these 2 angles related. So, if you're looking up above, the giant red triangle is this guy right here. And the purple triangle is this right here. Okay, if you copy this down, you would get that purple triangle right there. What do we notice is the same about figure 1 and figure 2? Well, that 2 is the same. Okay, the 2 is the same right there and right there. So if we copied that down here, that means this side length would be 2, and this side length would also be 2. That means that this tinier black triangle right here is an isosceles triangle, which means the base angles are congruent. So this angle A is congruent to this angle over here. Okay, let's label those angles using numbers. Okay, let me get some of this extra color out of here so we can see what's going on. So let's say this is angle 1, this is angle 2, and I need this guy too probably over here, so let's label him angle 3. I know the measure of angle 1 is equal to the measure of angle 2 because they are congruent based on that isosceles triangle. I also know the measure of angle 2 plus the measure of angle 3. Hey guys, those make a straight line. What does that add up to? 180. So I know the measure of angle 2 plus the measure of angle 3 equals 180. Well, I need to know how angle 1 and angle 3 are related so that I can figure out the 2 different cases of angle side side. Well, if 1 is equal to 2 and 2 plus 3 is 180, that also means 1 plus 3 is 180. That's the information that we need right there. So, going back to my original figure. Angle 1 is located in the corner right here. That's angle A in our first triangle. Angle 3, I also said was important from right here. Angle 3 is located right here. And that is this angle up here in this triangle. Those 2 angles are not congruent. What do? They add to 180. So that's the important part. If we have 2 cases, we're going to have this thing called the ambiguous angle. The ambiguous angle is angle A, because here and here we both have A's, okay, but they're not going to be equal to each other. Okay, it's ambiguous because it could be 2 different things. We also know that those angles are going to be supplementary. So in case 1, which we're always going to have 2 cases, okay, case 1, A is going to equal, let's say, X. Then in case 2, A is going to equal 180 minus X. So let's see what this is going to look like in our class when we have to solve a problem. So anytime you're given a triangle, well, here they didn't even give us a triangle. Let's draw. Anytime you're given a triangle where you have, let's say, A, B, C, and little b is 20, little a is 4, little b is 2. So anytime you are given angle, side, that's not an angle. Let's try that again. Angle, side, side. You need 2 cases. So case 1, you write everybody out. And case 1, we're going to use law of sines. It's amazing. It's my favorite. First, we need to figure out what is the ambiguous angle. What angle should I find first? Well, guys, look right here. If we're going to use law of sines, we need matching pairs. Okay, so I have matching pairs with B, and I have information about little a, so I can now find big A. So my ambiguous angle is the angle where I know the side, but I don't know the angle. If you try to use law of sines with C, you're going to have too many variables going on. You're not going to be able to solve it. So my ambiguous angle is A, circle it. After you find your ambiguous angle, you're going to use law of sines to find it. Now remember, law of sines will only give you an acute angle when you have to take the inverse, which we're probably going to have to do here. So this first angle will be acute, and then we'll subtract from 180 to get the second possible angle, which could be obtuse. Okay, let's use law of sines with A. So we're going to do sine A over 4 equals sine 20 over 2. I really just took this information right here and put it into law of sines. And then cross multiply. 2 sine A equals 4 sine 20. Remember, we don't type it till the end. So divide 2, divide 2. Whenever you have the word sine without a letter, what do you need to type in your calculator? The correct answer is you need the inverse. So I'm actually going to type second sine and then type that fraction in my calculator. So alpha y, enter. If you want the cubic fraction, 4 sine 20 over 2. Click enter, and you get measure of angle A is 43.16017778. Probably continues on further than that, degrees. In this section, I would like you to round degrees to the whole number. Yeah, I said it, the whole number. So this would just be 43 degrees. Hey guys, look, it's a cube. So go back up here and fill out the measured angle A is 43 degrees. That means to get the other A, you subtract from 180. They have to be supplementary. So 180 minus 43 gives you 137 degrees. Now, we can easily find information about both of these cases. Let's get some of this out of here. In the first case, your angles have to add up to what? 180. So do 180 minus 43 minus 20, and you'll get 117 right there. That is possible. That's legal. I have all positive numbers, and I only have one obtuse angle. Remember, you can only have one obtuse angle in a triangle. Okay, over here, let's do 180 minus 137 minus 20. That'll give me 23 degrees. Also legal, also possible, all positive, only one obtuse angle in a triangle. What's the only thing I'm missing? Oh yeah, little c. You're going to do law of sines again, twice, one for the first case and one for the second case. So if I do law of sines again, I'm looking for c. You want to use matching people, so a matching angle with a matching side, but you want to use the numbers that they gave you just in case you made a mistake. They gave me the b's, so I'm going to do sine 20 over 2 equals, I'm trying to find the c's, so I have to use the c's, sine 117 over little c. I'm going to cross multiply, c sine 20 equals 2 sine 117, divide sine 20. Do I have to type inverse sine this time? The answer is no, because I don't have the word sine left over here on the left. Here I had the word sine. I had to type inverse sine. Here I just have letter C, so I'm good to go. So I'm going to type alpha y, enter, 2 sine 117 over sine 20. Enter again, and I get this side is 5.210257592, probably go for it. Sides, we're going to round to the thousandths as usual, so this will be 5.210 for our first side, C. You still have to go to the other case and find this side, C. The only thing that's going to be different is angle C. So we're still going to use the matching people that they gave us. We're going to use sine 20 over 2. I'm going to use my B's, because that was given to me. I need to find C's. So I know the angle C. I know sine 23 over little c. You would cross multiply and solve that. I'm going to give you a second to do that on your own. If you solve that correctly, you would get 2.285. Okay, that was the worst case scenario. I gave it to you first. The worst case scenario is that there are two triangles. Remember the swinging side? Okay, so worst case scenario, there are two triangles. The next worst case scenario, let's find out. Okay, first thing, what is the ambiguous angle? It's the angle that has a side, but a blank in the angle spot. Okay, so B is my ambiguous angle. Okay, that is missing the angle information, but it has a side length. So we're going to use law of sines. In case 1, we're going to get the acute angle because the law of sines will only give us acute answers. I'm trying to find sine B, measure of angle B, so I'm going to use sine B over 20 is equal to, I need matchy people, so I'm going to use A's, sine 110 over 30. We cross multiply, we get 30 sine B equals 20 sine 110. Divide 30, divide 30. With sine B equals that fraction. Okay, I actually don't want to find sine of B. I want to find the measure of angle B. So when I have the word sine left over, I'm going to go to my calculator and I'm going to type the inverse to get the angle. So I'm going to type second sine, let me erase that blue line there, second sine alpha y, and then I'm going to type my fraction in, 20 sine 110 over 30. And the measure of my angle is 38.789. Now, I said angles can be rounded to whole numbers, so we're going to round that to 39 degrees. So sine B doesn't equal 39. The measure of angle B equals 39 degrees. So go back up, fill in 39 degrees. How am I going to get that other B? Oh yeah, everything adds to 180. So we're going to subtract that from 180, and we're going to get 141 degrees over here. Wait a minute. Over in case 2, can you have 2 obtuse angles in a triangle? If you try to subtract that from 180 to get the third angle, 180 minus 110 minus 141 is negative 71 degrees. This side does not exist. That is awesome. I get to cross it off and write D in. Do you get to stop solving the problem? No, you still have one perfect triangle on the left side in case 1. So for this one, you can do 180 minus 110 minus 39 to get the third angle. And check that in your calculator or your brain. You'll get 31 degrees. Then you'll perform law of sines again to find that missing side, side C. I want to use the matching people they gave me so that I don't mess anything up. So I'm going to use A again. I'm going to use sine 110 over 30 equals sine, I'm trying to find C, so sine 31 over little c. I'm going to give you a second to type that in your calculator. Cross multiply. Remember, I want you to round sides to the thousandths, so if you did that correctly, you would get 16.443. So now we're done. Okay, we're done with that problem. There was only one triangle that existed. Guys, we did 2 triangles. We did 1 triangle. Now, this is the best one. So sometimes it won't have it set up all pretty for you. You'll have to do it. So you go draw your triangle like you always do. You have A, B, C. We know it's not drawn to scale. Little a is 30, little b is 15, big E is 40. Oh no! They gave us angle, side, side. You should automatically be like, oh, this sucks. I need 2 cases. So case 1 and case 2. Sorry about this markboard right there. So we're going to write A equals B equals C equals for both of them. We're going to fill out the information that we already have. So little a is 30, little b is 15, big B is 40. That goes for both of them. What's the ambiguous angle? Remember, it's the angle where we know the side, but not the angle. So it's my angle A. So we do law of sines to find this. We do it in the first problem, and we'll get an acute angle for A. Well, maybe. Okay, let's do sine A over 30 equals sine 40 over 15. You cross multiply, you get 15 sine A, I like letters on the left, 30 sine 40. You divide 15, and you end up with the word sine A. I don't want to find sine of A, I want to find the measure of angle A. So in my calculator, I'm going to type the inverse to cancel out that sine. So second sine, and then type in your fraction. I'm going to do alpha y, 30 sine 40 over 15. Oh no, I got an error. That must mean that side is too short to reach the ground, and this triangle does not exist, which means this triangle does not exist, and your favorite answer in the whole entire world does not exist. So, in summary, whenever you have angle, side, side, you need to have two cases. Find your missing angle. Those two angles in those two cases will add up to 180, and you'll use law of sines a million times to find all of your answers. You could have two triangles, you could have one triangle, or if your calculator tells you error, you have no triangles, you get to cross everything off, and right does not exist. Have a great rest of your day, everybody.